All right, so these are 2.5 notes. And these are part 1. So we're going to learn about the fundamental theorem of algebra. We know that an nth degree polynomial can have at most n real zeros. So that is like when we had x to the 5th power, we could have 5 zeros for answers. In the complex number system, this statement can be improved. That is, in the complex number system, every nth degree polynomial function has precisely n zeros. So it doesn't mean that all 5 of them are real, but when we're dealing with complex numbers now, so like i's and square roots and stuff like that, we're going to have exactly how many our highest degree term has. So if our highest degree is x to the 5th power, we'll have exactly 5 zeros. Some of them can be complex, so have i's or square roots. Some of them can be real numbers. So in WebAssign, it asks you to leave your answers in linear factorization. So that's just like one step before your solution. So if we had like as our answers as x is equal to 5 and 4, linear factorization would be x minus 5 and x minus 4, like this. So if WebAssign asks you to leave your answers in linear factorization, it would be like one step before solving. So this step. Great question. Why is it minus 5 and minus 4? Because if this was equal to 0, we would add 5 to both sides. So then x is equal to positive 5. So you always change the sign when you put it into the parentheses.
Like you have to make that to be equal to our answer that we have.
Because it tells us that this is our answer. So then in order to get that as our answer, it has to be x minus 5. So it's always x minus the answer.
Why is it minus 5 and minus 4?
All right, for A, it says the first degree polynomial. This is x to the 1st power. That's our highest degree. So we know we're going to have one answer here, 1, 0. So when we set this equal to 0 and solve, add 2 to both sides, x is equal to 2. And that's our one answer. In B, how many answers are we going to have? 2, because it's x squared. So we would have to factor this to solve. What are 2 factors of 9 that add to negative 6? Negative 3 and negative 3. So we have x minus 3 and x minus 3. So then x is equal to 3 and x is equal to 3. So these are our 2 solutions. So even though they're the same thing, it's still 2 answers. All right, next we have a 3rd degree polynomial. So we know we're going to have how many answers? 3. How do we solve this one? Greatest common factor is x, so we can take that out. What am I left with? X squared plus 4. So x is equal to 0. X squared plus 4 is equal to 0. Subtract 4. X squared is equal to negative 4. Then what do I do? Square root. So what's x equal to? 2i. Awesome. Good job. So this is one answer, and then here we have 2 answers because it's the positive 2i and the negative 2i. So that gives us our 3 answers. 3 zeros. If this question asks us to leave it in linear factorization, so like the step before solving, so we're going backwards, we would have x, then we would have x minus 2i, and then x plus 2i.
Oh, so you just leave that x on the outside?
Yeah, we would just leave the x on the outside. Because it would be like x minus 0 when we write our answer, and that's just x. So this would be our linear factorization. All right, and let's look at D. How many answers are we going to have here? 5. What do I do first? Greatest common factor is x cubed. So then what am I left with?
X squared plus 9.
X squared plus 9.
So
So x
x equal to
is equal to 0. I have 3 of them because I have x cubed is equal to 0. So there's 3 zeros there. And then x squared plus 9 is equal to 0.
minus 9.
Subtract 9. X squared is equal to negative 9. So what's x equal to?
X equal
Plus or minus 3i. Awesome. Yeah. So in A, it factors this trinomial here into what we're used to factoring it as x squared minus 5, x squared plus 4. Now when we solve this, this would be x squared minus 5 is equal to 0, so add 5. X squared is equal to 5, take the square root. So what's x equal to? Plus or minus square root 5. So when we put that into our linear factorization, this would be x plus square root 5 and x minus square root 5 here. Now if we do the same thing for x squared plus 4, what do we have to do? Subtract 4. So x squared is equal to negative 4. What's x equal to? Plus or minus 2i. So this gives us an imaginary number. So our factored form here, without putting that I in it and leaving it as x squared plus 4, this is called irreducible over the reals. So that's when we don't have imaginary numbers in our answer. We can't reduce it anymore and still have real numbers. But in completely factored form, we know we can break down x into plus or minus 2i, so we could leave it like this, but this would just be completely factored. So the first one here is irreducible over the reals because we don't have any imaginary numbers in it. And then this one is completely factored here. All right, let's look at example 1. We have to write the complete linear factors and then state the zeros. How can I factor number 1? Greatest common factor is x, so I'm going to take out an x. I'm left with x cubed plus 3x squared minus 13x minus 15. Now what can I do? Can I group them? No, because I'm not going to be able to take out, if I took out an x squared here, I'd be left with x plus 3. I wouldn't be able to take out anything from here and be left with x plus 3. In order to group, you have to have the same insides after you take out your greatest common factor from each group. So we can't group. What else can we do when we can't factor?
Quadratic. Oh wait, no, it's not quadratic.
It's not quadratic. Synthetic division, but p over q, right? So same thing. List all of our factors of the last over all of our factors of the first, and then use synthetic division to test it out.
Plus or minus 1.
So plus or minus, we have 1, 3, 5, and 15. And then for our factors of our leading coefficient, that would just be plus or minus 1. So what do you want to try first?
You use 1, right? So I use 1.
We can use 1 first.
Oh, you're supposed to use something else.
It doesn't matter. You can use any one of these first. You can use 1, 3, 5, 15, negative 1, negative 3, negative 5, negative 15. It's easiest to use 1 first just because it's going to be like the least amount of math to do. Like if I used 15 first, I'm going to be multiplying everything by 15, which is going to be annoying.
And that counts as one of your answers, right? The 1.
If it works.
And if you get 0?
Yeah. So we have 1, 3, negative 13, and negative 15 inside of our box. Drop down the 1, multiply, we get 1, add, we get 4, multiply, 4, add, we get -9. Multiply, it's not going to work.
-9. I do -1.
Let's try -1. So multiply, we get -1, add 2, multiply, -2, add, -15, multiply, +15, add, and we get 0. So -1 works. So one of our answers is x is equal to -1. Now from here, I'm left with,
X to the third plus 2x squared.
I started with x to the third,
X squared.
so it'd be x squared plus 2x minus 15. Ryan, did you have a question?
Could you write x equals 0?
Yeah, I could write x equals 0 here because I know that that's going to be 0. So that's going to be another one of my solutions.
And then you have x plus 5 and x minus 3.
My two factors of -15 that add to +2 are 5 and -3. So this would break down into x plus 5 and x minus 3. Set them both equal to 0. So what do I get for x? -5 and x equals +3. So my other two solutions are -5 and +3. From the start, how many solutions did I know that I was going to have? 4. And I have 4. So these are all of my zeros. And then it asked me to write it in linear factors. So that would be in my parentheses. X, I always flip the sign when I put it back into my parentheses. So when I change into linear factors. So x plus 1. 0 is just x, so I'll put that out front. Then I have x plus 5 and x minus 3.
Question.
Because I took out an x at the start,
Oh.
so that would just be x equals 0. Yep. And then when you write your answer in complete linear factorization, you always have to put equals 0. So that is my complete linear factors. So don't forget to put that equals 0 at the end. All right, let's look at the next one. How do I factor this? P over Q. So what are my factors of 40?
1, 2, 4, 5, 8.
10, 20.
Awesome. 1, 2, 4, 5, 8, 10, 20, 40. I think that's all of them. Yeah. And then my factors of my leading coefficient are just plus and minus 1. So what do I want to try first?
1.
Let's try 1. In my box, I have to put 1, -7, 2, and 40. Drop down the 1, multiply, -6. Multiply, we get -6. Add, bless you, -4. It's not going to work.
Try 4.
Let's try 4. So multiply, we have 4. Minus 7 would be -3. Multiply, we get -12. Add, -10. Multiply, -40. Add, we get 0. Awesome. Good guess. So one of our zeros is 4. And then I can use what I just divided my answer here as x squared minus 3x minus 10, and I can factor this. So what are two factors of -10 that add to -3? -5 and +2. So this would be x minus 5, x plus 2. So x is equal to 5, and x is equal to -2.
Do you have to put x equals 5, x equals -2? Can you just put like x minus 4 next to it and finish for that?
But it asks to list the zeros also.
But isn't it imply that like those parentheses give you those zeros?
If it says list the zeros, then you have to list the zeros. Yeah. So these are the zeros, and then my linear factors would be x minus 5, x plus 2, and what else?
X minus 4.
X minus 4. I can always double check. I know I'm going to get 3 zeros as my answer, so I have 1, 2, 3. So I know I found them all. Number 3. How can I factor?
P over Q.
Could do P over Q. Anything else?
You could.
Could you multiply the x and the 6, and that would give you 6?
So do I have 2 factors of 6 that add to 7?
1 and 6.
1 and 6. But in my parentheses, what am I going to put since I started with x to the 4th? So x squared plus 6 and x squared plus 1. P over Q would definitely work here too. But don't forget, if you're doing P over Q, you have to put 0x cubed here and 0x here.
Yeah.
Why?
Because when you do synthetic division, you have to have those zeros as your placeholders. So then we solve. We have x squared plus 6 is equal to 0. X squared plus 1 is equal to 0. So x squared is equal to negative 6. Take the square root. What's x equal to?
I
root 6.
Or plus or minus that.
Plus or minus I square root 6. And then we do the same thing here. Subtract 1, so x squared is equal to negative 1. Take the square root. What's plus or minus I? Awesome. So these would be our zeros. And then in our factored form, I would have x minus I square root 6, x plus I square root 6, x minus I, x plus I. And then I know that I needed 4 zeros, 4 answers here. I have 2 here and 2 here. 1, 2, 3, 4. Equal to 0. I almost forgot. I forgot in the last one too. This should be equal to 0. Number 4. How can I factor? Grouping. Yay. So what am I going to take out of the first group?
Squared.
X squared, and what am I left with?
X minus 2.
X minus 3, and what can I take out of the second group? Negative 2, and what am I left with? X minus 3. So then I have x minus 3, and what's going to go in my second parentheses here? X squared minus 2. Then I just set each one equal to 0. Add 3, so x is equal to 3. Here I'm going to add 2, so x squared is equal to 2. Take the square root. What's x equal to? Plus or minus square root 2. So here I have 1 answer, and then here I have 2, which told me that I need 3. So I'm good there. And then I just have to put it in my linear factorization. So this would be x, what comes next? Minus, okay, I could say minus square root 2. And x plus square root 2. And then what else? X minus 3 equals 0.